Hello everyone, so in this video, let us talk about a medium level problem from LeetCode. The problem name is minimum number of operations to sort a binary tree by level. Okay, let us talk about the problem statement first. So problem statement goes like this, that you're given the root of a binary tree with unique values, as you can see in the input tree. Now, in one operation, what you can do is that you can choose two nodes at the same level. Okay, at the same level, you can choose two different nodes and you can swap their values. Okay, pretty much simple. The one operation you will understand. Now you have to return the minimum number of operations needed to make the value at each of these levels sorted in a strictly increasing order. Now each level of the binary tree should be now sorted in a strictly increasing order by doing these operations. Now how can you do that? First of all, the first idea which comes to my mind is that okay, I have to somehow sort them. So sorting in a level order traversal, because in every level I have to somehow sort them. So first of all, I have to somehow know all the numbers in a particular level. So I have to somehow know them. So let's first find out using a level order traversal over the binary tree. So there are multiple videos. I have also made multiple videos on level order traversal on a binary tree. You can check those out. We will be doing it using binary best first search, that is BFS, to over this tree. Now, once we get all the numbers in a certain level, we have to somehow sort them. Now, sorting them is again one of the not too difficult challenge, but let's take some small example to understand that how we can sort them according to the given constraints. Let's take an example that we have the numbers in a given level like this. That is 1, let's say 3, let's say 4, let's say 6, and let's say 5. Let's say like this is the like the numbers I have got in a particular level. And I have to somehow sort them. So what I'll eventually do is that I will do a for loop over all of them from left to right, because what is my main idea? I have to somehow place the numbers in the correct order. Okay, now 1 is already in the correct position. Now the next number among all of them should be next minimum, that is 3. So I have to somehow place 3 here. Now because I cannot directly place 3, I have to somehow swap the number that is here with where 3 is. So 3 is here, so I will swap it with this. It will become 3, and eventually 4 will come here. So when I'm doing a for loop over this array, and when I come to this position, 4 is now, because being swapped with 3, comes to its right position automatically. So I will not do anything, because in one swap I have actually like corrected 2 positions. So it can also happen that in one swap I will correct only 1 position, but it can also happen that in one swap I can correct 2 positions automatically. So that is also done. Now, so I will not do anything here. I will move to here. Now again, this is not at the correct position. It should be 5 here. So I will swap these two values. 5 will come here, 6 will come here. And automatically it will be swapped. So what information I need to do to actually do this operation? First of all, I have to somehow know that where 3 is in this array. Okay, then only I can swap this number with 3. So which means that I have to somehow store a map of what number is there at which index. Okay, that is one thing that I have to need to know. Then again in this I have to know that what is the next number I have to place here. So I have to know that somehow I have to place 1 here, 3 here. So what I can do is I can make a copy of this array and sort them. If I know the copy of it and I sort them, I eventually I directly just do a for loop over here. I understand that if 1 is here, the next number should be 3, and in the original position I have 4. So it means that I have to somehow replace and bring 3 here, which is at this position, and I have to put 4 at this position in the 3 array. So I have to take this array into consideration and do changes in the original array, that is this, in the map. So I have a map data structure that will store the indexes and the number itself, so that I can like directly just do the manipulation on this array, taking this as the final array that I want to use. Don't worry, I will show in the code part now, but that's the whole idea that I will use to first sort this whole array, that is a copy of it, and just matching that, keep matching that. If the number that is here is matching with here, I will not do anything, but if doesn't match, I'll find out what is the number that should be placed here and where it is actually by using this map, because this map is storing the index. I'll go to that number, place this here, and put the number in the and that particular position in the actual array or in the actual map that is using just store this value, and just keep on doing this. If I'm doing one operation, I will just increment the swap, and I will do it for all the levels for all these particular arrays. In the end, we just print out a total answer. That's it. That is pretty much like the solution for this particular problem. Let's talk about the code part now. So let's move down to first here. So this is the actual, you can say, BFS or level of traversal over this complete binary tree. So what we're doing is that we have made a let's say queue and inserted the first node inside the queue, as is the total answer that will be doing it. Keep on iterating over the queue. Okay, then for every level, find out its size and keep on iterating over a level. So this is doing a BFS, and this is iterating over a complete level, this internal while loop. Now, in a particular level, what we'll do is that we will take all these numbers and push that in some, let's say, temporary vector that is creating this array of all the numbers inside a level, and now inserting the next level inside the queue. This is that somehow that I want to now move to the next level. So I'm moving actually the next level nodes inside the queue for the next level and pushing all the current level nodes value inside this temp array so that I can sort them. So now this is done for pushing it. This is for the next level. Come out of this while loop, and now we have all the numbers that I need to sort in a current, let's say, row of the binary tree. Now I will call this calculate function to actually calculate out how many operations that are required here, because this code will become very because I will have to actually do the same thing. So instead of doing this here, this is just accountable for doing the PFS, and this calculate function is actually accountable to finding out the total number of operations that are required. Now we will call this sending out this temp array, and the total answer is returned from this calculate function. The total number of operations that will be done, it will be added for all the levels, and in the end we just print out the answer. Now understand, let's say, how this actual calculate function works. Let's move up. Okay, so how we will be doing this calculate function? It will take a swap. How many swaps we have done? This is the total size of the array that we have. Now we have two maps actually. I'll tell you why these two maps are required. But let's this like map of nums and map of position. This maps of num is actually used to store. So these two maps are used to find out somewhat what is the actual state of the numbers that we have. So let's also draw it out. The example that we have taken, that is 1. Let's say this was actual 4365. Okay, so what we are first storing in the first map is the value and its index. So whatever value I have mapped to its index. And also I have told you that these are unique, so no worry that the coinciding or colliding of anything that will not happen. So what will happen is that we have the value mapped to its index. So which means that 1 is stored at index 0, 4 is stored at index 1, 3 is stored at index 2, and so on. That is stored in this map, and this map is just a reciprocal of it, that at which index which number is stored, which means that at 0th index 1 is stored, 4th index, oh sorry, first index 4 is stored. So it's just a proposal. This is number to index mapping, and this is index to number mapping. I'll tell you why this is important, but I have stored these two mappings. Now I have these two mappings which actually defines the complete state of the original array that we have. Now what we'll do is that I will sort them. I will sort the actual array. Now sorting this will convert this into the actual array that we want to transform into. Okay, let's say this transform into this new array. I'll remove some part. Let's say it's transform into 1, 3, 4, 5, and 6. This is the actual array, which means that I have to somehow transform this to this. Now let's take an example that let's do a for loop. Now this for loop is actually doing iterating over this complete array from left to right. I will match that whether this and this are same. If these are same, what eventually means that in the sorted array I want 1 here, and the actual array also 1 is here, which means that they actually is the correct position. I don't actually have to do something. So what I'm actually doing is that this is the actual num. So what is the number that need to be put here? That is you can say that if a of I, the first number a of I in the actual sorted, so let's say in the sorted array 1 is here. So if 1 is here in this array, where is 1 in the actual array? So I need to find out the index of it, where is actually 1 in the actual array. So I will use the index. So I will actually use this map to num number that will return the index. I will put 1 here, and it will give me that 1 is actually at the 0th index. And where is 1 in the actual index, actual like the new array, you can say, also at the 0th index. So if they're actually on the same index, which means that like it is same, like we don't actually have to do something. So I will just continue on. Or else if they are not at the correct position, I have to somehow swap this out. Let's move forward for the next. Let's say the next number is 3. So I will find out that whether 3 is in the new position, where is 3 in the old position. 3 is actually at the index, you can say, 2. And in the new array, 3 should be at index 1. What it eventually means is that I have to somehow in the old index replace, put 3 here and put 4 at the position where 3 is. Okay, so where I should be putting 3, 3 should be put at the index 1. So this is the current index. This is the current number. The current number a of I. A of I is the after sorted array, which is 3. So the current number is a of I, that is 3 here. And what is the old number? Old number, which means that this is the old array. According to me, this is the new array. New array. So what it eventually means that what is the old value, like the old number in the same position in this array. So if this is 3, the same number here, that is at the same position, as you can see, in the same position. That is why I need this position vector to know that the position map, to know that what is the number that is here. So that I have the index number mapping also. So that I understand that, okay, 4 is here at the original array. Okay, so 4 is here. So now I have to somehow swap 3 with 4, because I have to need to swap two numbers now. So I have to need to understand that where 3 is and where is the number at this actual position is. So 4 is here. So now I have these two numbers. I have to now find out the new and old position. So 4, as you can see, so this new position, so 3 is here. Its new position is I, that is this index. And its old position I actually have to find out. Now I just need to swap them out. So if I need to swap them out, I understand that I just imagine that 3 comes to this position. Now I have to somehow bring 4 to this position. So 4 has to be bring to that position where 3 was. So 3 was at this old position, and I have to also update in both the maps. That I have to bring 4 at this position. So 4 now, new position is this where 3 was. So I have to just update them in the maps itself, because map is actually storing that, like the storing the state. So now eventually it means that 3 has come here and 4 has come to this position. So when I come to this position doing a for loop over here, I understand that now this is 4, and when I will check in the map, 4 was also updated inside the map. So is 4 updated inside the map, which means that 4 has come here, which means that it is updated. So I don't have to do anything because 4 is already there. I hope you understand. You can just do a brute force over this complete for loop. It will become much more clear to it, nothing much complicated. And that's it. That's the complete logic to actually sort them out. And whenever I do a swap like this, I will just increment the swap by 1. In the end, I will just print out the number of swaps that will be done in the end for a complete level, and just add it for all the levels. Pretty much simple. That is the complete logic and code part for this particular problem. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next decoding and bye. And let us talk about the actual time complexity of this particular problem as well. So I am doing let's say level traversal. So level traversal is O of n, and for every level, so I am doing, you can say for every level I am doing you can say log n for sorting as well. Now the number of nodes may vary on every level, but the maximum if you can take it is n log n, because for every level these are independent, these are not multiplication, these are independent events. Because for every level, so I'm doing a for like O of n to iterate over all of them, but for every level they will be like, let's say maximum of let's say log n. So log n is this height, but let's say I have to iterate over all of them and just get the value. So it will be maximum of 2 to the power n. 2 to the power n, the total number of nodes, and the maximum number of nodes here will be, let's say 2 to the power 0, 2 to the power 1, whatever depth is there. Depending about that, we will get the total number of nodes in here, and that will be pretty much small here only, that is n log n. And then log n will be sorting here, and then doing this again for loop will be O of n only, but the maximum will be n log n. So total overall will be n log n only, because that is a very much larger value in compared to other values as well. And we are doing taking some maps as well. So O of n, to just store out these maps and all of that. So O of n only. So that's the whole idea and the logic part for this particular problem. Thank you for watching this video till the end. I will see you in the next decoding, and bye.